Thank you very much for Ariel to share the multi-year evolution for the Facebook infrastructure to convert from zero SLA to predictable SLA for the dynamic resource management. Thank you. Now we have everyone back here. I think it's time for us to have a panel discussion and a Q&A. Right, so we have some topic we want to discuss with everyone to share the experience for the similar topic, and we have very specific question for different presenters. And anyone online, please feel free to ask a question, and all the time I will try to present your question to the speakers as soon as possible. Cool. To start with, actually, I think it's we want to start with the topic of different resource management or cluster management solutions. Nowadays, as we know that Kubernetes are getting very popular in the industry, so the Azure he presented Azure Kubernetes services. So this has provided a standard solution for a lot of customers. At the same time, I think Amit talked about Uber's usage of Mesos and Yarn. I think in Facebook, we also published a paper about the Twine. So I want to start with Amit and Ariel to talk about what do you see as the future of cluster management system. Do you believe there will be further consolidation of solutions in this space in the future? Who want to start first?
I can go first. Right. So yes, Kubernetes definitely figures in our strategic plans. As we are looking at the next generation of infrastructure, we are evaluating Kubernetes. But then there are challenges like we've already built an ecosystem around the existing platform. So we need to make sure we have the same capabilities, or if not, we'll have to build the same capabilities for Kubernetes. Like, for example, Morecore itself does not come out of the box with Kubernetes. So we have to build that. I think for Kubernetes, we're definitely looking at the stateless compute side of the workloads first, and then there is a desire to move more workloads like big data and also like storage to a single platform like Kubernetes. We're not there yet.
Yeah, Ian, I think you called out that Kubernetes provides a lot of standardization and is something that across industry is becoming more popular. For Facebook, we have sat down with leads of Kubernetes as a platform to understand what it offers and the future direction. And it is absolutely advantageous when it comes to things like its extensibility and usability. But for Facebook, some of the other things that we need to keep in mind are our scale. And the various decisions that we want flexibility in making for custom hardware, custom infrastructure, how we think about capacity management, budgeting, and sort of all of the resource accounting components that really make sort of having our own infrastructure and our ecosystem sort of a good fit for us personally.
Cool, thank you for sharing. So on the similar topic, I want to ask Chi. So what do you think is the biggest difference between running a Kubernetes cluster in on-premise environment versus running in a public cloud?
Sure. I think it's really the need, not really like which one is better than the other. Of course, there's differences like what the cloud can bring compared to what you can get from on-prem is already there, like the elasticity and the diversity of diverse hardwares that you can get, so that you don't have to purchase and maintain yourself and refresh. But in general, I can see that certain industry, for instance, AT&T, this kind of operators, they just cannot lift everything into the cloud. They have to have something running on the edge, and in those cases, they have to maintain on-prem. But Google and Azure both are trying to get there as well, like Azure's Arc system and Google's Anthos are both trying to manage the Kubernetes clusters, both on-prem and in the cloud, to cover the need. Because even for people running their on-prem systems, they would still like to use Kubernetes to manage their infrastructure and their workload.
Cool, thank you. Yeah. So I think for the next set of questions, I want to move to the topic of dynamic resource sharing and increased utilization, because this is a one of the biggest opportunity by running a different workflow together with a shared cluster management systems. And I see a lot of questions in that regard. To start with, I want to ask both Amit and Ariel, because in both of your talk, you mentioned in Uber's More or Facebook's Optimus give unused machine in their entirety to move between different workloads. What are the pros and cons about this approach compared to co-locating workloads on the same machine and potentially overcommit resources at the host level? And what do you think about the future? Do you think in the future we will move more towards the resource sharing on a single host or not? I mean, I know Amit has touched this topic briefly in the presentation, but there's a lot of questions. So could you try to clarify this point again?
Ariel, you want to go first, or should I go?
I'll let you take it, and I'll chime in after.
Okay. All right. Yeah. So same host co-location. It would be the natural way to do things, right? But it can, in theory, it can give you the maximal benefit from your cluster because you're using all the nooks and crannies in your cluster to fill up whatever opportunistic workloads you have. But from our perspective, I think getting the most efficiency is not as important as ensuring reliability. And that's where that isolation problem that I alluded to in my talk comes in, right? We want strong isolation guarantees between different kinds of workloads. And that's putting them on separate hosts kind of works better for us. There's also the other thing about, if you have to put them on the same host, then you also need to have these workloads being managed from the same clustering system or same scheduling system, right? Like you couldn't have, or for example, in R, we have this heterogeneous way of doing Peloton and Mesos for the stateless workloads and then Yarn for the data workloads, right? And we would have to have a single system which is managing both kinds of workloads before we can do the same host co-location. And if we didn't, then we would have to come up with some really complex way of sharing the host level resources between these two entirely different systems. So given these challenges, I think right now we're going to stick with putting them on different hosts and not put them together on the same host.
Yeah, man, I think what you had called out in terms of resource isolation are absolutely things that we consider as well. One of the other driving factors actually for Facebook to focus on sort of elastic and reusing full machines comes from the hardware decisions that we've made. So power is actually one of the limiting resources for how we scale up our infrastructure. And this is physical power. So the way we've actually chosen to scale up is purchasing more power efficient, but smaller machines, so less CPU and less memory resources. And that actually means most of our services can and are encouraged to actually optimize for using all of the resources on the machines. And so there's actually less opportunity for Facebook's physical infrastructure to sort of pursue overcommit and sharing of resources on the same stack. But it is something that we'll continue to explore as our workloads and our physical infrastructure evolve.
Cool, thank you. So Chi, now I want to move to your topic because both Amit and Ariel has talked about how to share resources between different workloads in their environment. So how does AKS think about this? Does AKS trying to share resources between different Kubernetes clusters?
Sure. So when we talk about that, we have to think about the security, right? Because what AKS serve is really workload coming from different companies and the different users, and including hackers and malicious users. It's not just serving one company, even though in one company, yes, you also sort of like multi-tenancy, but at least the intention, they are not malicious. So for us, the customer workload, we have to use hypervisor separation, basically VM, to separate them. We cannot allow them to share the same infrastructure, at least right now. We do have another system I can talk briefly later, sort of multi-tenancy. But the control plane side, because it's a controlled code, it's all Kubernetes code, we control what is running there. So we use multi-tenancy to share the infrastructure to achieve higher resource utilization. In fact, AKS right now still, I believe, is still the only one and remain free for customer. We at least provide the free option for customer to use AKS control plane. And that is achieved via a more efficient resource utilization by sharing the common infrastructure. And with that, we can also be more elastic. Some customers, some clusters use less resource, like they deploy less pods, they have less number of nodes, then they can use less resource of the control plane. For others, let's say they have thousands of nodes, they have tens of thousands of pods. For those, we will scale up their control plane, especially the API server, scale up and scale out of the API server to accommodate the load.
Cool, thank you very much. So in that regard, I think there are several questions about, when we run the workload, if we want to dynamically shift resources or run them in a more controlled fashion, we need to understand their performance better. So there are several questions about that. So I want to go through them. The first question I want to see is how when we run for this question is for Qi, when we run the workload in public cloud for Kubernetes workload for in public cloud. How can we measure understand the performance difference across different hardware and the different host OS?
Yeah, so usually you don't need to worry about the host OS. Sorry, so there's different terminology in cloud provider. We call the bare metal, the host running bare metal as a host, and then the VMs. So if you have more questions, feel free to clarify there in the chat. So cloud provider publishes these metrics. Like in my demo, what I did was clearly it was limited by the VM's throughput, IO throughput, and by the OS disk throughput. When I pick those, I need to try to make sure they match each other. So the ones in my demo, they capped at 100 megabytes per second. So for each type of hardware you choose, or each type of VM or disk you choose, they have this performance published. So make sure when you create your cluster, you pick the right hardware as they match. What's the other question? Sorry.
I think this is the question, right? So how do you handle the difference, the basic potentially heterogeneous infrastructure underlying the
Yeah, and the Kubernetes itself right now, especially AKS, we support the multiple node pool, so you can mix and match. For AKS, we support a Linux node, various Linux node, GPU node. You want to accelerate networking, you want the NVMe. All those can be co-located in the same cluster, but they can belong to different node pool. With that, they come with these labels coming with a node, so you can use a node selector to decide where your workload will go to, which node pool, which hardware it will go to. So that is very powerful. Just because Kubernetes support that kind of functionality. And then we also mix match Linux and Windows node. I don't know how many people still use, like here in this audience, use Windows, but the Microsoft definitely have customers still heavily rely on Windows. So we support them to run both Windows and Linux workload in the same cluster for ease of managing.
Cool, thank you. In the same regard, there's a question for Amit. Do you account for nonlinear behavior of microservices?
No. So we've made the assumption that we have a business metric, essentially, which based on which all services get sized, and we assume that it grows linearly with that. It works both ways, right? I mean, if it is sublinear, then we are losing opportunities for gain some more efficiencies. but it's never usually not the case with it's super linear because we do a lot of testing and figuring out, making sure that we have enough capacity for microservices all the time.
Cool, cool. Yeah, so I think a important topic shared today are about dynamic sharing resources between batch workload and the more real-time workload. So there are several questions in that regard for both for Amit and Ariel. How fast could the infrastructure handle sudden workload, sudden load spikes for real-time services? Who want to go first?
So from the Morcor perspective, we usually are able to get in these evict all the batch workloads and get the host in like a matter of less than 5 minutes whenever we need to. But generally, we tend to be a little more conservative when we are forecasting how much we need. We are already accounting for any potential spikes or a spike to a certain extent, and then we are making sure that we already have that capacity pulled in upfront, so that any such, we basically want to reduce risk.
Yes, very similar for us as well in the order of minutes. Within that time, we're responding to sort of the trigger or the sort of request for additional capacity from the spike, cleaning up host state, making sure that, when the sort of owner machine or sort of the owner of that machine would like those resources back, that it's in a clean, healthy state, configured to, what their expectations are.
Cool. Thanks. So in the dynamic resource sharing, there are a lot of planning involved. There's a lot of analytics involved. So there's some question about that regard. So there's a question for Amit. How is AI involved? I assume this is about and predict the resource usage.
Well, the short answer is AI at this time. We have a very simple model for how we forecast what we need. But going forward, we want to look at doing this better, like being a little more careful about how we predict what is needed. But at this time, we are doing very simple forecasting.
Cool. Ariel, anything you want to share in that regard in terms of prediction and modeling?
Sure. We also build models to understand both sort of the forecasted supply as well as our understanding of the demand. For us, we actually pull in explicit planning signals to understand what that supply and demand looks like, as opposed to purely sort of project based on historical signal, because we know of product launches, data center launches, infrastructure scales that are coming up. So those actually help us become much more accurate than simply sort of forecasting from historical signals.
Cool, thank you. So Chi, there are several questions about, how does AKS customers understand their workload and potential troubleshooting better. So one question is, in the face of AKS problems, how to differentiate whether an issue is caused by Azure or the customer?
That's $1 million question, by the way. It's a very good question. I think today my talk, a lot of that is around this. Yeah, it's very challenging, and we are doing a lot of work in this area to facilitate, for instance, use eBPF tools on the node and to really monitor what's going on in their I/O network, to extract as much signal as possible to find out whether it's a customer workload or Kubernetes component or Azure infrastructure, because that's the problem. Our team is basically in the middle. We get burned by Azure's stability issues sometimes, and we get burned by customer own workload. Like yesterday, some customer running a Java app on AKS is finding a ticket to support couldn't figure out, eventually get to my team, and we look at, customer, their own Java app is getting their own I/O throttled. So this is a really common, but right now, without lacking of those, eyes and ears on the customer workload on the node, it is pretty challenging for us. And of course, we're also leveraging many of the underneath monitoring toolings, monitoring logging that Azure provides. So internally, just to be frank, internally we have an internal diagnostic tool that absorb tons of messages together into this UI tool to facilitate the engineers on calls to diagnose. But on the other hand, we also face the information overload problem. We just have so many signals, as you can see, right? Kubernetes itself has many metrics, and then the Azure infrastructure has many, and the customer can use so many different services, from load balancer to VM is a very basic one. But then there could be glitches in the data path. Let's say the UDP drop rate suddenly spike, or TCP retransmission rate. All these signals can overwhelm the on-calls, let alone and customer themselves. How to extract useful information, give the meaningful, actionable signal back to customer is the current challenge as well.
Cool. Yeah, thanks for all the inside views. Next, there are several questions related to the preemption when it comes to dynamic resource sharing. So one question for Ariel is, when Optimus preempts a process because the infrastructure has a spike, does Optimus maintain a log of processes that are being preempted, or does the application have to take care of handling preemption scenarios? Like, basically, can application be agnostic to Optimus resourcing handling scenarios?
Yeah, that's a great question. So one of the things that we think about is, how we expect a service to behave when they get a preemption signal. So one of the nice things for Optimus capacity is that we're actually on the same cluster management and workload deployment system as workloads that are not on Optimus resources. So what Optimus does is change the expectations of capacity availability, but still using the standard deployment workloads. And so when a preemption does happen, the service is expected to sort of take the time that is given within seconds to shut down, gracefully drain, do any type of checkpointing that it would do for a sort of standard preemption trigger. And in the sort of case that it needs to spin up a new task, it would have to do that same warm-up. So we do not handle any sort of carryover of state or tasks when it gets preempted, but we do use sort of standard capacity start and shut down workloads.
Cool. I guess there's a related question for Amit. When you consider preempted batch tasks, do you consider things like remaining compute time?
At this time, we are not considering the remaining compute time for that jobs, because sometimes it's not easy for us to estimate how much compute time is remaining on the job. We consider other things like, like I mentioned, killing the application master in a Spark job is not really the best thing to do, because it basically means the whole job fails. But if you can kill off an executor, that's still fine, because there is inbuilt resiliency within the Spark system to spin up another executor if needed.
Cool. Thanks. Yeah, I mean, earlier on we talked about a challenge of sharing workload on the same host is because of potential isolation. But there's one question, right? So have any of you explored the workload sharing on the same host when workloads are very different account? Let's say, compute intensive versus IO intensive.
Yeah,
Anyone want to?
I can take that for now. Yeah, so this is kind of solved problem for Kubernetes, right? So Kubernetes give every container, you can specify your request and limit on CPU, memory, and in C group V2, they support IO as well. So as long as you specify the limit of your container there, Kubernetes scheduler will just magically bin packing them together to maximize utilization of the host.
Cool. Yeah, there's one question for Ariel. How does Optimus compare to Spot instance? I mean, I assume this is a reference to AWS.
That's a great question. So there are absolutely a lot of similarities in the mechanics of how we allocate capacity, sort of source the resources. I would say some of the biggest differences are actually how we think about sort of pricing and the market. So for sort of a public cloud and Spot instances, it is very much pricing driven in terms of how much resources you have access to and when you leverage those resources. For Facebook, because we are sort of a centralized, product, we do think about our capacity and capacity distribution a bit more globally. So we sort of focus a bit more on those persistent use cases, pulling that into planning and being at least somewhat more predictable in terms of how much resources that we current out. So it comes down to how we think about capacity allocation and resource governance.
Cool. There are several questions about planning in general in this dynamic shared theme. So there's a question for Amit. What's the over commit ratio in your clusters?
So we've been experimenting with different values, and right now it's between 10 and 20% what we're looking at, and we probably want to go higher, but at this point we feel this is a safe spot.
Okay. Similarly for Ariel, for customers who are using dynamic leasing, how do they plan their capacity?
Absolutely. So this is one of the things that I had mentioned in that we do sort of take our future planned supply and provide a signal on how much we anticipate to be available. And this actually factors into how we sort of set budgets and distribute the capacity across our various products. So what we encourage teams to think about is understand, what their top line metric is, whether it's sort of quality of ranking, workload completion rate, landing times for various back workloads, and set expectations in a range. So what you would get with or without that additional capacity, and making sure that you can sort of function both with and without the aggregate capacity as it will fluctuate. So one of the things that I mentioned is we don't just sort of talk about this expectation, but we set aside infrastructure for actually testing and taking that capacity away in a sort of a periodic way, simply to ensure that service expectations align with what our infrastructure can offer.
Cool. There are several questions about interaction between Kubernetes and the underlying control plane for AKS. So this is a question for Qi. In AKS, is there a bigger Azure level control plane running under all the AKS control plane? If so, does Kubernetes control plane need to coordinate with the Azure control plane in any way?
The Kubernetes component, I wouldn't say control plane, components like some controller managers do need to interact with Azure control plane. And that's why I mentioned in the talk that it poses a new challenge to a cloud provider like Azure. Because before, Azure designed the control plane as less dynamic, right? You do not need to satisfy very high QPS and a very high churns. But with Kubernetes, it starts to face the challenge. For instance, Kubernetes has this component called the cluster autoscaler and also the cloud provider. These components need to interact with Azure control plane frequently to scale in and scale out, and to remove the dead or sick node VMs and bring in new VMs. So it's very dynamic. That's how we also save money for customer, right? Customer do not need to worry about how actively manage the size of their cluster, because the cluster autoscaler together with the horizontal pod autoscaler are gonna automatically scale your cluster in and out. But to do that, it needs to interact with Azure control plane frequently. But for workload, customer workload, we do not need to interact with Azure control plane.
Cool. Yeah, it's interesting you mentioned auto scaling. I think Ariel also mentioned auto scaling in Facebook. So there's a question for Amit. Does Uber do real-time auto scaling of microservices? Could auto scaling be used to free up resources for optimistic workloads?
Yeah, that's actually a great question. Yeah, the idea would be with auto scaling, like you can shrink down services when your services don't need as much compute power, and then you can shrink them, grow them back up during other times of the day. And this would be another way of trying to extract more from your capacity instead of doing overcommitment. The thing is, you need to get this autoscaler, real-time autoscaling right? Make sure it works with a large number of your services. And unfortunately, at Uber, we don't have that yet, so we could not leverage auto scaling for more core. But we may be looking at building something for other reasons, and then we could use that for running opportunistic workloads.
Cool, cool. Yeah, so we just asked Amit about the buffer factor when it comes to planning. So there's a question for Ariel. Ariel, how does power affect dynamic leasing decisions?
Sure. So we think about power actually in multiple phases. So I had mentioned that part of our decision making is that power is one of our sort of primary constraints when we think about scaling up. Even so, we actually fairly aggressively subscribe the power that we deploy with respect to the workloads that we're running. And so one of the needs that arises from that is we also want sort of real-time power management, just to ensure that wherever we may have oversubscribed, that we can keep our fleet in sort of a healthy state. One of the systems that we have previously published about is called Dynamo, and that's actually what we have in play for assessing whenever workloads sort of use more power than we may have anticipated in a particular hotspot or within our data center. Now, bringing that back to Optimus and Elastic Resources, when we sort of deploy or sort of allocate opportunistic resources to workloads, there is always that risk that it exceeds the power envelope that we've set aside. And so we do two things. One is proactively sort of assess how much power we anticipate allocating a resource to for a particular workload would take and assess whether we have sufficient supply. And the second one is if we have made the determination that we anticipate sufficient supply, but for whatever reason, either spikes in other parts of the physical infrastructure or on that workload, we have our real-time Dynamo system kick in and do various types of power capping or reshuffling of allocations to protect our physical infrastructure. So we do think about it in quite a few layers.
Cool. I guess next question is also from Ariel. For Optimus, you said the events like Friends Day, etc., when the capacity required by batch applications spikes, the infrastructure is communicated and the infrastructure adjusts its tasks. Is this all automated?
That's a great question. So we have various components that are automated. Breaking it down a little bit, for a specific workload, such as Friendship Day, those batch workloads, when onboarded to our generic auto-scaling platform, can take a look at what the throughput is and sort of what the demand requirements are and scale up how it's deployed automatically. Now, we do have demand control in place. So things like quotas and limits may limit how quickly a sort of service in particular or a workload can scale up. And so we have automation that allows our services to scale up to the various checkpoints and limits that we put into place.
Cool. I think this question is likely for Qi. Essentially, containers and VMs each have its own benefits. Are different services executed within the VM or container based on infrastructure or based on load-aware parameters?
I would say neither. So the difference between VM and container is mainly the separation, right? The security boundary. VM provide more secure boundaries than container today, unless you run like the Kata container, those kind of hypervisor containers. But today the containers provide a better packing, more efficient resource utilization. And also for deployment, you have all your dependencies packed in the same container. So when you deploy, like many examples for Spark, right? Why Spark on Kubernetes is so successful today compared to before running on Yarn is because they pack all their dependencies into the container and deploy without worry about whether dependency has been deployed. But if you're running on VM, you have to worry about all those dependencies yourself. You have to, and I don't know how many of you use those copy to deploy before. Don't you remember always worry about the oops, what you have seen on your environment is different from what I saw on my development, on my environment. But with containers, this problem is solved.
Oh, yeah. So a question for Ariel. Ariel, how much buffer do you allocate to counter the factor like environmental factors?
Absolutely. So I did mention environmental factors as one of the things that we consider. What it comes down to for us are various risks that we anticipate and how we sort of want to buffer against those. So environmental, we think about sort of various different parts of the stack that may become unavailable, whether that's sort of access to the network, various physical power, sort of networking, cooling components, as well as a region, right? Those are sort of different tiers and aggregations that we think about. For the amount of buffer that we set aside, it's typically not for one specific factor, but we do take a look at sort of all of the different components compounded together and sort of the correlation of those happening as we set aside buffer. So we do sort of think about it in totality.
Cool, thank you. Okay, so I guess there's a question about extensibility of AKS. How much extensibility does AKS offer to its customers? The slide mentioned scheduler extensions and the CRD and controllers. Is it full extensibility that Kubernetes offers? If so, what percentage of deployment actually develop their own extensions, and what are the major challenges in supporting them?
Yeah, so I have to admit it's not a full all the extensibility that the Kubernetes provide, because we run the control plane. We do not run the control plane. We do not enable, for example, alpha features on managed Kubernetes, as you probably derive from my earlier talk. The support load is gonna just be too much. However, we do try to be as vanilla Kubernetes as possible. So we give as much extensibility to the customers as possible. In terms of customization, it varies. For instance, the core DNS customization, how many use customized configuration or customized DNS server? I did a stats about 5% of the customer use that, so not very high. But the webhooks are very commonly used, probably 30 to 50% depending on the time of customer use them. And also like our gatekeeper, many of the security features are implemented as the webhooks. So that is widely used.
Cool. So there's a question for Ariel. What's the confidence interval for the availability SLA of elastic capacity in Optimus?
Yeah, so we actually have more than one. So the way we think about our capacity, it really comes down to sort of how we forecast out our supply. So we provide various confidence intervals for the amount of supply, and the sort of more resources that you're looking to use, the lower availability that we expect, because it's sort of a total amount that we're asking out of the infrastructure. To give a sense of sort of the ranges that we think about, the highest availability that we offer is in the sort of 90% or higher availability target that we're setting. And the lowest end of that range is sort of opportunistic, right? Entirely sort of best effort in terms of how much capacity that we provide. And all of this factors into sort of similar to spot instances, but how we charge and bring that back into pricing.
Cool. I think there's a question maybe has been touched before, but I wonder anyone want to share more insights on this topic. There's a question about what's a different approach on the market. Kubernetes, I think the question is about Kubernetes small clusters up to a couple of thousand nodes versus Mesos, which runs tens of thousands of nodes. So there's this general question about comparison of those approaches. Does anyone want to share more insight to this comparison?
I can start if it's okay. Number one, Kubernetes is not just a couple of thousand nodes anymore. Like Google GKE support up to 15,000, I believe. So AKS is also getting more into bigger ones. We haven't been focused on that yet because that hasn't been a common demand from customer. Like very, very few customers ask for that, and a lot of times they realize soon that the blast radius is probably not worth the going that big, because if you have a huge cluster and it's busted somehow, if there's some problem, it will be hard to recover. So a common trend is actually manage, let's say up to 1,000 nodes, but a bunch of clusters together and do sort of federation, not the Kubernetes way of federation, but sort of multi-cluster service mesh, multi-cluster load balancing to achieve that same goal. But in terms of like I think Mesos is good as well, and Kubernetes both can get there. It's really like Amit mentioned earlier, is how much investment you already have in the system versus like and Kubernetes definitely get more attention from the industry, the community, and have a lot of more features developed into it. So yeah, Amit, you have more to add?
Yeah, I mean, I absolutely agree with Chi about the fault domain. A large cluster means your fault domain is much larger, so you don't want that. But on the other end of the spectrum, if you have many small clusters, the operational overhead is way higher. Like we run our own clusters, so we feel the pain. So we have to have this happy medium in between where the clusters are not too big or not too small. And so that's sort of where we come from. And another thing with other larger clusters is that, so this cluster, this Kubernetes or Mesos is not operating in isolation, right? There are a lot of other services around it, right? So they need to be also able to scale at the same rate. If they aren't able to scale, then we can't really have a large cluster on our side. It really doesn't help. Ariel, what if you want to add something?
I think Amit and Chi, you definitely touched upon sort of the key components. Thinking a little bit about how Facebook does it as well, being able to scale not just individual services, but sort of groups of services with interconnected dependencies, while thinking about latency. These are all sort of factors that tie into how we scale up individual clusters and sort of those units of deployments that we think about.
Cool. Yeah, I think this is a great way to conclude our session. I think it's time to wrap up. Thank you very much. Thank you for all the presenters to come here to discuss those interesting topics. And thank you very much for everyone online to participate and ask those questions. This is a great event. Looking forward to see everyone in next week or the next session. Thank you. Goodbye.
Thank you. Bye-bye.